Hello everyone, welcome back to my channel Love My Tutorial. Today we are going to discuss about the last exercise of polynomials, that is exercise 2.4 of Ncert syllabus and exercise 9.4 of Karnataka state syllabus. Now let us start with the first question. Verify that the numbers given alongside of the cubic polynomials below are their zeros. In this first question, in the first part, we have to verify the given numbers are the zeros of the polynomial. And the second part of the question is also verify the relationship between the zeros and coefficients in each case. In the second part, we have to verify the relationship between the zeros and the coefficients in each of the cases. Now, let us start with the first question. The first question is 2x cube plus x square minus 5x plus 2, and the zeros are given, that is 1 by 2, 1 and minus 2. Now let us solve this. To verify that the given numbers, that is 1 by 2, 1 and minus 2 are the zeros of the polynomial, we have to put the values in the given polynomial. That is, in the given polynomial, that is 2x cube plus x square minus 5x plus 2, in the first part, put x is equal to 1 by 2. That is, p of 1 by 2 is equal to 2 of 1 by 2 whole cube plus 1 by 2 whole square minus 5 of 1 by 2 plus 2, which is equal to 2 into 1 by 8. That is, here 1 cube is 1 itself and 2 cube is 8, that is 1 by 8, and 1 by 2 square, that is 1 by 2 whole square is nothing but 1 by 4 minus 5 into 1 by 2 is 5 by 2 plus 2, which is equal to, here 2 1s are 2 and 2 4s are 8, which is equal to 1 by 4 plus 1 by 4 minus 1 by 2 plus 2. Now, taking the LCM as 4, we get 1 plus 1 minus 10, that is 5 into 2 is 10 plus 8, 4 into 2 is 8. Here minus 5 by 2 into 4 means, here 2 1s are 2 and 2 2s are 4, that means 5 into 2 is 10. I repeat again, by taking 4 as LCM, we get 1 by 4. 1 by 4 into 4 is 1 itself, and here also 1 by 4 into 4 is 1 itself, and again here 5 by 2 into 4 is 2 1s are 2 and 2 2s are 4. So 5 into 2 becomes minus 10 plus 2 into 4 is 8. Here in the last part 2 into 4 is 8. So the required value for p of 1 by 2 is equal to 0. Now put x is equal to 1 in the given polynomial. That is, put x is equal to 1 in 2x cube plus x square minus 5x plus 2. Therefore, by substituting the value for x, here we get p of 1 is equal to 2 of 1 cube plus 1 square minus 5 of 1 plus 2. Again, here p of 1 is equal to 2 plus 1 minus 5 plus 2. Therefore, the value of p of 1 becomes 0. Now, put x is equal to minus 2 in p of x. By putting the value of x is equal to minus 2 in the given polynomial, we get 2 of minus 2 whole cube plus minus 2 whole square minus 5 of minus 2 plus 2. Therefore, here 2 cube becomes minus 8. That is 2 into minus 8 plus 2 square minus 2 square becomes plus 4, and here minus into minus becomes plus, 5 into 2 becomes 10 plus 2 as it is. So by solving this, we'll get P of minus 2 is equal to 0. Therefore 1 by 2 comma 1 and minus 2 are the zeros of the given polynomial. Here we have verified the first part of the question, that is we have verified that the given numbers of the zeros are of the polynomial. Now let us jump on to the next part of the question. In the next part, we have to find the relationship between the zeros and the coefficients. Here let us take alpha is equal to 1 by 2, beta is equal to 1 and gamma is equal to minus 2. Here the sum of the given polynomial is equal to, that is alpha plus beta plus gamma is equal to minus coefficient of x square divided by coefficient of x cube. That means half plus 1 plus of minus 2 is equal to minus 1 by 2, because here the coefficient of x square is 1 and coefficient of x cube is 2. Therefore alpha plus beta plus gamma is equal to minus coefficient of x square divided by coefficient of x cube, that is minus half into half. It is verified. The next part is alpha beta plus beta gamma plus gamma alpha is equal to coefficient of x divided by coefficient of x cube. That means half into 1 plus 1 into minus 2 plus minus 2 of 1 is equal to minus 5 by 2. That means half minus 2 minus 1 is equal to minus 5 by 2. Here also we have to verify that LHS is equal to RHS. That means minus 5 by 2 is equal to minus 5 by 2. That is coefficient of x is minus 5 and coefficient of x cube is 2. The next part, alpha into beta into gamma is equal to constant term divided by coefficient of x cube. In the given polynomial, the constant is 2 and coefficient of x cube is also 2. That means half into 1 into minus 2 is equal to minus 2 divided by 2, which is equal to minus 1 is equal to minus 1. Therefore, the relation between the zeros and coefficient is verified. Now, let us jump on to the next question. The next question is, that means the given polynomial is x cube minus 4x square plus 5x minus 2, and the zeros are 2, 1 and 1. Here also in the first part we have to verify that the given numbers 2, 1, 1 are the zeros of the polynomial. To verify that, we have to put x is equal to 2 in P of x, that is x cube minus 4x square plus 5x minus 2. Here P of x is x cube minus 4x square plus 5x minus 2. By putting the value of x is equal to 2, we get P of 2 is equal to 2 cube minus 4 into 2 square plus 5 into 2 minus 2, which is equal to 8 into minus 4 into 4 plus 5 of 2 minus 2. By solving this, we will get P of 2 is equal to 0. That is P of 2 is equal to 0. Now put the value for x is equal to minus 1 in P of x. That means P of 1 is equal to 1 cube minus 4 into 1 square plus 5 into 1 minus 2. P of 1 is equal to 1 minus 4 plus 5 minus 2. Therefore, the value of P of 1 is equal to 0. Therefore, 2, 1, 1 are the zeros of the polynomial. Here it is verified that 2, 1, 1 are the zeros of the polynomial. Now, let us solve the next part of the question. That is, in the next part we have to find the relationship between the zeros and the coefficient. To find the relationship between the zeros and the coefficient, let us assume that alpha is equal to 2, beta is equal to 1 and gamma is equal to 1. Here alpha plus beta plus gamma is equal to minus coefficient of x square divided by coefficient of x cube. That is 2 plus 1 is equal to minus of minus 4 divided by 1. That is coefficient of x square is minus 4. Minus into minus is plus 4. That means 4 is equal to 4. LHS is equal to RHS. Here also it is verified that alpha plus beta plus gamma is equal to minus coefficient of x square divided by coefficient of x cube. Again, alpha beta plus beta gamma plus gamma alpha is equal to coefficient of x divided by coefficient of x cube. Here 2 into 1 plus 1 into 1 plus 2 into 1 is equal to 5 divided by 1. That is, here 5 is the coefficient of x and 1 is the coefficient of x cube. That means 2 plus 1 plus 2 is equal to 5 and coefficient of x divided by coefficient of x cube is also 5. Therefore, LHS is equal to RHS. Here also it is verified. In the next part, alpha beta into gamma is equal to minus a constant term divided by coefficient of x cube. That is 2 into 1 is equal to 2 and constant term is minus 2, which is multiplied by minus, we get minus of minus 2 is equal to 2 itself. Therefore, the relationship between the zeros and the coefficient is verified. The next question is find the cubic polynomial. Here we have to find the cubic polynomial with the sum, that is alpha plus beta plus gamma and sum of the products of its zeros taken 2 at a time. That means alpha beta plus beta gamma plus gamma delta and the product of its zeros, as product of its zeros means alpha into beta into gamma, as 2, minus 7 and minus 14 respectively. That means we have to take alpha plus beta plus gamma is equal to 2 and alpha beta gamma plus alpha gamma alpha is equal to minus 7 and alpha into beta into gamma is equal to minus 14. Now let us solve this question. We already know that the general form of cubic polynomial is ax cube plus bx square plus cx plus d, and the zeros of the polynomials are alpha, beta and gamma. Therefore, alpha plus beta plus gamma is equal to minus b divided by a, which is equal to 2 divided by 1. Here let us assume that a is equal to 1. In the next part, it is given that sum of products of its zeros taken 2 at a time. That means alpha beta plus beta gamma plus gamma alpha is equal to c divided by a. That is coefficient of x divided by coefficient of a. Here it is coefficient of, that is minus coefficient of x square divided by coefficient of x cube. Here a is nothing but coefficient of x cube and alpha beta into gamma is equal to minus d divided by a. That is minus of constant term divided by coefficient of x cube. That means alpha beta plus beta gamma plus gamma alpha is equal to c divided by a, which is equal to minus 7 by 1, and again alpha into beta into gamma is equal to minus d divided by a, which is equal to minus 14 divided by 1. Thus by comparing the coefficients we get a is equal to 1, b is equal to 2, c is equal to minus 7 and d is equal to 14. Now substituting the values of a, b, c and d in the general form of cubic polynomial, we get x cube plus 2x square minus 7x plus 14. Therefore, the cubic polynomial is x cube plus 2x square minus 7x plus 14. Let us solve the third question. If the zeros of the polynomial x cube minus 3x square plus x plus 1 are a minus b, comma a plus b, find a and b. Here we have to find the zeros of the polynomial. So let us find the zeros of the polynomial. That means comparing the given polynomial, that is x cube minus 3x square plus x plus 1 with the standard form of the cubic polynomial, that is px cube plus qx square plus rx plus t, we get p is equal to 1, q is equal to minus 3, r is equal to 1 and t is equal to 1. Given zeros are a minus b, comma a and a plus b. So instead of taking alpha plus beta plus gamma, here we will take a minus b plus a plus b is equal to minus coefficient of x square divided by coefficient of x cube. That means here a plus a is 3a and here minus b and plus b get cancels. That means the remaining value is 3a, which is equal to minus of minus 3 divided by 1. That is coefficient of x square is minus 3 and coefficient of x cube is 1. Therefore, here 3a is equal to 3 and a is equal to 3 divided by 3, which is equal to a is equal to 1. Since a is equal to 1, the zeros of the polynomial are 1 minus b, 1 and 1 plus b. So the product of zeros, that is alpha into beta into gamma, is 1 into 1 minus b into 1 plus b, which is equal to minus of constant term divided by coefficient of x cube. That means here 1 minus b into 1 plus b. By using the identity a plus b into a minus b, so this becomes 1 square minus b square, which is equal to minus of constant term is, here the constant term is 1 divided by coefficient of x cube. Coefficient of x cube is 1. That means minus 1 divided by 1 is minus 1. Here 1 square is 1 and minus b square is b square itself, which is equal to 1 minus b square is equal to minus 1. B square is equal to 1 plus 1, which is equal to 2. That means here 1 minus b square is equal to minus 1. Minus b square is equal to minus 1 into minus 1. By multiplying both sides with minus, we get b square is equal to 1 plus 1. That is b square is equal to 2. B is equal to square root of plus or minus 2. Therefore, a is equal to 1, b is equal to root 2 or minus root 2. Now let us solve the fourth question. If two zeros of the polynomial x to the power of 4 minus 6x cube minus 26x square plus 138x minus 35 are 2 plus or minus root 3. Find the other zeros. Here it is already given that 2 plus root 3 and 2 minus root 3 are the other zeros of the polynomial. That means the two zeros are 2 plus root 3 and 2 minus root 3. Therefore, the factor x minus 2 plus root 3 into x minus 2 minus root 3. Let us consider here x minus 2 as a and root 3 as b. That means by using the identity a plus b into a minus b, we get x minus 2 whole square minus root 3 whole square. That means x square plus 4 minus of 2 into 2x minus here square root and square get cancelled. That means minus 3. Here x square minus 4x plus 4 minus 3 and x square minus 4x plus 4 minus 3 is plus 1 is the factors. That means the factor we got is x square minus 4x plus 1 is a factor. To find the remaining zeros of the polynomial, we have to divide the polynomial x to the power of 4 minus 6x cube minus 26x square plus 138x minus 35 by x square minus 4x plus 1. Now, by dividing the polynomial x square minus 4x plus 1 divided by x to the power of 4 minus 6x cube minus 26x square plus 138x minus 35, we get to divide the polynomial, we have to multiply the factor, that is x square minus 4x plus 1 by x square. So x square into x square is x to the power of 4. 4 into, that is minus 4x into x square is minus 4x cube. 1 into x square is plus x square. By subtracting this, we get here plus x to the power of minus 4 becomes minus x to the power of 4, and here minus 4x cube becomes plus 4x cube, and here plus x square becomes minus x square. That means here x to the power of 4 and minus x to the power of 4 get cancelled. Here minus 6x cube plus 4x cube is minus 2x cube, and here minus 26x square minus x square is minus 27x square. By taking the remaining terms for further division, we get plus 138x minus 35. Now to solve this, we have to multiply the factor x square minus 4x plus 1 by minus of 2x. Then we get minus 2x into x square is minus 2x cube, and minus 2x into minus 4x is minus 8. Sorry, minus into minus becomes plus, that means plus 8x square, and minus 2x into plus 1 becomes minus 2x. Now by subtracting this, we get minus 2x cube becomes plus 2x cube, and here plus 8x square becomes minus 8x square, and here minus 2x becomes plus 2x. So minus 2x cube and plus 2x cube get cancelled. So minus 27x square and minus 8x square is minus 35x square, and here plus 138x and plus 2x is plus 140x and minus 35 as it is. Now multiply the equation by minus 35. That means x square into minus 35 is minus 35x square and minus 35 into minus 4 is plus 140x, and minus 35 into plus 1 is minus 35. By subtracting the remaining polynomial, we get here minus 35x square becomes plus 35x square, and plus 140x becomes minus 140x, and here minus 35 becomes plus 35. Here minus 35x square and plus 35x square get cancelled, and here also plus 140x and minus 140x get cancelled, and minus 35 and plus 35 is also get cancelled, so the remainder is 0. So hence the 0 is the remainder. So we can clearly say that x to the power of 4 minus 6x cube minus 26x square plus 138x minus 35 is equal to x square minus 4x plus 1 into x square minus 2x minus 35. That means x square minus 2x minus 35 is a factor. That means x square minus 2x minus 35 is also a factor of the given polynomial. That means we can easily find the other two zeros of the polynomial, that is x square. Here minus 2x we can write it as minus 7x plus 5x minus 35 is equal to 0. Here x into x minus 7 and plus 5 into x minus 7 is equal to 0. So the factors are x plus 5 into x minus 7 is equal to 0. So the other two factors are x is equal to minus 5 and x is equal to 7. Therefore, the value of the polynomial is also becomes 0 when x is equal to minus 5 and x is equal to 7. Hence, the other zeros of the polynomials are minus 5 and 7. Now let us solve the last question of this exercise and also the last question of this chapter, polynomial. If the polynomial x to the power of 4 minus 6x cube plus 16x square minus 26x plus 10 is divided by another polynomial x square minus 2x plus k, the remainder comes out to be x plus a. Find k and a. Now let us solve it. By division algorithm, we already know that dividend is equal to divisor into quotient plus remainder. Dividend minus remainder is equal to divisor into quotient. Therefore, we can say that x to the power of 4 minus 6x cube plus 16x square minus 26x plus 10 minus of x plus a is perfectly divisible by x square minus 2x plus k. That is x square minus 6x cube plus 16x square minus 26x plus 10. Here I am multiplying by minus x minus a is divisible by x square minus 2x plus k. Now let us divide x to the power of 4 minus 6x cube plus 16x square minus 26x plus 10 minus a by x square minus 2x plus k. So to divide this further, we have to multiply x square minus 2x plus k by x square. So this becomes x to the power of 4 minus 2x square plus k x square. So by subtracting this, we will get x to the power of 4 and minus x to the power of 4 get cancels. Here minus 6x cube plus 2x square is minus 4x cube, and here plus 16x square minus kx square. Now let us take minus 26x for further division. Now to divide this, we have to multiply by 4x. That means minus 4x into x square is minus 4x cube plus 8x square minus 4k into x. Now let us subtract this. We'll get these two things get cancelled, that is minus 4x cube and plus 4x cube get cancelled. Here this becomes 8x square minus kx square, and this is 26 minus 26x plus 4kx. So I will write this polynomial again by taking x square as common, 8 minus k of x square, here minus 26 minus 4k of x, and again now I am taking 10 minus a for further division. Now to solve this, let us multiply the polynomial by plus 8 minus k. That is, multiply x square minus 2x plus k by 8 minus k. Therefore, we will get 8 minus k of x square. Here 2 into 8 is minus 16 minus 2k, and x as common, plus here 8k minus k square. So now let us subtract this. This becomes minus, plus, and again this minus. So we can cancel these two terms. The remainder is minus 10 plus 2k, 10 plus minus 10 plus 2k of x plus 10 minus a minus 8k plus k square. Now it can be observed that here the value of minus 10 plus 2k of x plus 10 minus a minus 8k plus k square is equal to 0. That means minus 10 plus 2k is equal to 0 and 10 minus a minus 8k plus k square is equal to 0. For minus 10 plus 2k is equal to 0, we get 2k is equal to 10, k is equal to 10 by 2, which is equal to 5. The value of k is equal to 5. That means we got the value of k, which is equal to 5. Now put k is equal to 5. Put k is equal to 5 in 10 minus a minus 8k plus k square is equal to 0 to find the value of a. So 10 minus a minus 8, by putting the value of k we get 8 into 5 plus 5 square is equal to 0. 10 minus a minus 40 plus 25 is equal to 0. So minus 40 plus 25 plus 10, we get 5. That means minus a minus 5 is equal to 0. Therefore a is equal to minus 5. Hence the values are k is equal to 5 and a is equal to minus 5. So this completes the chapter polynomials. So thanks for watching. My videos are available on YouTube and Facebook. So please like, share, subscribe, follow and don't forget to leave your comments in the comment box. Thank you.